Before we go on to our quiz, we need to finish up the last few steps of our design process here. So in the last set of slides, we were looking at this practice example with a centrifugal fan here. And here are the first 6 steps in our cookbook. We had done all these steps and we'd found the number of teeth, and now we're ready to go on to the next step, the chain length. Now, if you are out in the forest somewhere and you don't have access to the tables that we're going to look at, all you've got is some chain and a calculator, you could do a rough calculation with what you know about geometry. You could figure out roughly what is the half of the circumference of each of these sprockets and what is the hypotenuse of this triangle on each side, and you could approximate the chain length if needed. But that's not precise, and so what we use is this more accurate method with this weird looking formula. There is an actual equation for chain length that has a lot more stuff in it than this, and if you look at engineering textbooks, kinematics textbooks, you can find those full equations if you like. What manufacturers do is they provide you these simplified versions and tables with numbers on them. And we don't know what these mean yet, but that's okay. They give you tables where you look stuff up to simplify your life. So here is this formula. This is out of our book, and it's provided by Morse chain. And what are those things? C is the center distance in pitches. S is the total number of teeth. K is some number out of this table, and then there's C, the center distance again. So let us work through these numbers for our example one by one. First, the center distance in pitches, C. All right, we're using chain with a 1/4 inch pitch, number 25 chain. That means in every inch there are 4 pitches, 4 pitches per inch, because there are 4 1/4 inches per inch. So 4 pitches per inch times 12 inches gives us 48 pitches. Our center distance is 12 inches, which means it's 48 pitches. 4 pitches per inch times 12 inches center distance gives us 48 pitches of center distance. So that's the C in our formula. Now let's look for S. S is the total number of teeth, those two added together. So we have 40 teeth plus 80 teeth equals 120. Our S number is 120. Now let's look for D. D is not in this formula, but D is in our table. So D is the number of teeth in the big sprocket minus the small sprocket. We have 80 teeth minus 40 teeth. That means D is 40. Now we use our table. And notice in the table there is a column with D in it and a column with a corresponding K value. And these columns go all the way down and then continue up on the next column, go all the way down, continue up on the next column. So this is how they've squeezed many, many numbers into one table. Our D number is 40. So that means our corresponding K number is 40.53, which doesn't mean anything, but that's the number we're going to plug into our formula. So now we found the C, center distance, was 48 pitches. We found the S number was 120, and we found the K number was 40.53. So plugging those numbers into this formula, 2 times C plus S over 2 plus K over C. And if you punch all those numbers into your calculator, you will come out with an answer of 156.84 pitches. That's how long a chain you need. Can we buy 0.84 of a chain length? No, we can't, of course. So we have to round off the number of pitches. We could round up, that's the next closest whole number, we could round up to 157 pitches, but what's wrong with that? That's an odd number, and if we go with 157 pitches, our customer is going to have an offset link. So why don't we round to an even number? We could go up to 158 or down to 156. Either one is okay. I know 156 is closer, so you might want to go there. There are so many pitches here, it doesn't matter a whole lot. And then we figure out what kind of lubrication we need. There are different methods going from least expensive to most expensive, and of course we want the least expensive. So the least expensive, if we can have it in our particular chain drive, is type A. It's a manual system. Think oil can. Think somebody with one of those, those oil cans we used to have in our barns. They were made of brass, and you push them, and they make this nice whoop noise. It's like that. That's the manual method. Or you could have a device that drips onto the chain. The medium cost is a bath where the chain comes down and dips into a sump filled with oil at the bottom, and then continues on and dips again every time it comes around. Variation on that is having a disc that slings the oil around. And then the most expensive but most thorough method is a continuous stream or spray that constantly sprays oil onto the chain. So now that we've finished looking at our example, let's figure out what kind of oil we need. And here's our horsepower ratings chart. We looked up our 1800 RPM. We came down to a horsepower of 2.93, and notice that in this chart all these horsepower numbers land inside the range that's called type B. Type B is bath or disc lubrication. So according to this chart, the horsepower that we found requires a type B lubrication method. We can't use the oil can. We have too many horsepower. We're going with type B.